Number 6 on the back page of your review for Unit 3, an arithmetic sequence, that means it's adding or subtracting, has a first term of 2, first number of 2, and a sixth number of 17. We need to find out what it's going by. So 17 minus 2 is 15. 6 minus 1 is 5. So we know that it's adding 3 every time. And we want to know what term will the output number be 56. So the output is 56. We need to know what term number it is. So we could just keep adding 3 until we get there, 9, 10. And I don't know when it's going to be, but we could just keep adding 3, 29, 32, 35. So we're not there yet. So 13. I can just keep going here. 35, that's 38. 41, 44, 47, 50, 53. I'm real close. One more, 56. So it is the 19th term. This is not the only way that you can do this problem. If we know the first number is 2, then we know 2 plus, we know it was adding 3. 2 plus 3 and then x minus 1. We could set that equal to 56 and actually solve this for x like we would a regular equation. So if I distribute the 3, 2 plus 3x minus 3, and then combine the like terms, 3x would be minus 1 if I combine the like terms. And then if we just solve and add 1, we get 57. And then if we divide out 3, beautifully, we get 19, just like we got the other way of doing it. So it doesn't matter, you choose which way you would prefer. Number 7, same type of question because I wanted you to have more practice with this. It says the second number is 8 and the sixth term of 12, so 4, 5, 6, 3, 4, 5, 6. Is negative 12, and bottom take away top is negative 20. 6 take away 2 is 4. So negative 20 over 4, we know that the slope is negative 5. It's subtracting 5 every time. And it says if the value of the output is negative 72, what is the term number? So again, we could really just keep subtracting 5, so negative 17, negative 22, negative 27, 32, 37, 42, 47, 52, 57, 62, 67, 72, and negative 77. What do we want? Oh, 72. So that would be 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we got that number on the 18th term. Again, we could set this up as an equation. The second number is 8, and it is subtracting 5. And I would put x take away 2 because we are using the second number. And I would equal that to negative 72. I would distribute. I get negative 5x. A negative times a negative 2 would be positive 10. And if we combine 8 and 10, we get 18 minus 5x is negative 72. If I take 18 away, I have negative 90, and then divide out negative 5, and sure enough you get 18, just like we had the other way to do it. Write out the explicit form for the nth term of the geometric sequence. That just means write the explicit form. The third, this tells us the third number is 18, or negative 18. And the common ratio, it is multiplying by 3. So we know 1, 2, 3. The third number is negative 18. It is multiplying by 3 every time, going this direction. And so, on the test, it is going to have the explicit form written with the first term. So it'll look like this. We know it's multiplying by 3, and it'll have x minus 1 as an exponent. So what we're looking for, since it's a minus 1, we're going to have to go backwards to the first term, because we have to have the first term if we're minusing 1. So if we divide 18 by 3, we can go backwards and we'd get negative 6. If we divide negative 6 again by 3, we end up with negative 2. So our explicit is negative 2 times 3 to the x minus 1. Same thing, except we're given the fourth number. Again, it says it is geometric. We are multiplying by 4. Multiply 4. So we've got 1, 2, 3, 4 is negative 80. So the fourth number. And we know that it's multiplying by 4 going this direction. And we want to know explicit form. So we need the first number, because that's how it'll be multiple choice on the test, and it's multiplying by 4, and it'll have an x minus 1. Could we put an x minus 4 here and then just write negative 80? You bet. That is correct, because we know the fourth number is negative 80. So yes, we could do that. However, on the multiple choice test you're taking, it's going to want you to do minus 1 and go backwards to the first term. So we're going to divide 4 out of 80, negative 80, and we're going to get negative 20. Divide it again, and we get negative 5. Negative 5 doesn't divide 4, so it's just going to be negative 5/4. And so, and it'll be a fraction, so we would just leave it as negative 5/4. Done. What is the fifth number of the geometric sequence? This means the first number is 3, and it is multiplying by 4. See how the 4 is multiplying to the fn minus 1. To the previous term, it's going to multiply 4. So we really could just write out, we need the fifth number, we have the first number, so we could just times by 4. Times by 4. We could keep going, 192 and 768. So the fifth number is 768. Or, if you prefer to write out the explicit form and plug in a 5, we know the first term is 3. It's multiplying by 4. And if it's multiplying, we need an exponent, x minus 1. And because we want the fifth number, just plug in a 5 now into our calculator. So 3 times 4 to the 5 minus 1. Sure enough, you get the same exact answer that we have, 768. What is the seventh term of the geometric sequence? Again, same thing. The first number is negative 6, and we want 2, 3, 4, 5, 6, 7. We know that it is multiplying by 5. So if we multiply 5 and we just keep going all the way to the 7th, the numbers are going to need more space. And the next number, 93,750. That is our seventh term, the answer number, or if you prefer to write the explicit equation, we know the first number is negative 6. It is multiplying by 5 every time to the exponent x minus 1. And again, we could just plug in a 7 for x, type it in our calculator, and get the answer that way. And again, sure enough, our answer is the same as what we had there. Write the recursive form of the sequence. If you notice, well, in this case, 3 times what is 24? It's multiplying 8. Oh, we should decide if it's geometric or arithmetic. If you look, the numbers are getting huge really, really fast. So I knew it had to be multiplying, even though I didn't say that beforehand. It is multiplying, and in this case, if you keep multiplying by 8, sure enough, it works every time. And so if we want recursive, you can put the 8 and then fx minus 1. Or if you prefer, you can put fx minus 1 and then multiply 8 at the end. Both of those are fine for answers. 13, an explicit. Write an explicit form that best matches the recursive. We know that so we want explicit, and in actually this case on the test, your explicit form is going to want the 0 term, and you'll notice this by the multiple choice answers that are given to you. You'll realize that you want the 0 number. So we know that, I'm going to make a table this way. We know that the first number is -3, and it is adding 5 every time. So that would mean this is 2. If I add 5 again, that's 7. Add 5 again is 12. So if I go backwards and I take 5 away, I would get -8. So we know that that was to go backwards, but we know that every time we're repeatedly adding 5, adding 5, adding 5. And so that would mean we've got fx. In this case, the 0 term is -8, and we're adding 5 every time. And if it's the 0 number, we really don't have to subtract anything. So it could be written this way, or you could write 5x minus 8, which is really how it's going to look on the test. If you wanted to, you really could just write it as the regular using the first term like we've done before. So if we do that, we'd use -3. It's adding 5 every time, and then x minus 1. But what you'd have to do from here is you'd actually have to distribute the 5 and combine like terms. So -3 plus 5x minus 5, and then if you combine those, we get 5x minus 8, which is exactly what we have either way we go. So it doesn't matter. If you prefer to just use the first term, write it out, and then simplify, that'll get you to the answer, or you can just use the 0 term. Which sequence best matches the explicit function? Notice here that there's no -1, therefore the 5 is really your 0 number. But the easiest way to go here is just you want the first, it's showing the first 4 numbers, so 1, 2, 3, 4. The easiest way to go is just to plug in a 1 for x and get your answer. In this case, it'd be -10. If you go again and you plug in a 2 for the x, we would get 20. Again, if you plug in a 3 for x, you would get -40. And again, if you plug in 4 for x, you would end up with 80. So in this case, our answers match up with answer C choice. An arithmetic sequence has a first term of 4. Okay, so I know I'm going to need a slope here. A first term of 4, and it has a fifth term of 12. So I'm going to find out what it's going by. 12 minus 4 is 8. 5 minus 1 is 4. So 8 over 4 is 2.